We're going to go ahead and get started again. So, people can grab their seats. We're going to go ahead and get started. And so this morning, the first section here this morning, we talked about, kind of an overview of Azure. We showed how you can use app service to deploy code. We set up a CI/CD pipeline and talked a little bit about DevOps, and then showed off kind of the overall end-to-end experience. This next section here, we're going to go deeper now and dive into data. And then I'm going to talk about containers, and we'll do some container-driven development. And then we'll cover serverless and build some serverless apps as well. So, obviously data, everyone here is building an app, is almost certainly using a database in some way, shape, or form. And across Azure, we have a couple different options, obviously, for how you can use data. You can use VMs and run everything you want inside Azure. We also then have a bunch of as-a-service offerings that give you the flexibility of actually just using a database as a service, and we provide all that infrastructure for you. And whether you're using SQL, whether you're using MySQL, whether you're using Postgres, whether you're using MongoDB, whether you're using a variety of other NoSQL options, we provide all those now as a service, and we'll actually walk through great examples of all those in a little bit. How many people here are actually using SQL Server, by the way? Great, thank you. So a lot of SQL users, and SQL Server today is the most popular commercial database out there. And for people who don't know, we just shipped a fantastic update to it called SQL Server 2017 about 3 weeks ago, and you can download and use that now. And it is by far the best release of SQL that we've ever done. It's also the first release of SQL that works not just on Windows, but also works on Linux. And is available fully production ready on Linux. Yep. Cool. And it also works inside containers. And so you can actually use it inside containers, both for production, but what we're seeing a lot of people do now is actually use it as part of their CI/CD build pipeline. And so you can actually spin it up in a Docker instance, do all your testing really, really fast against it, and then just nuke the container when you're done. And it actually enables a lot of great organizations, including many here in New York that we've been working with, to really enable some pretty awesome new scenarios. In addition to being able to run everywhere, the other thing that's cool about it is it has in-memory database support. That's available on all tiers, including the free Express edition. And that in-memory data support also supports machine learning models built now in Python and R that can actually run in the database and that you can actually use for runtime operational applications and deliver richer intelligence within your apps. So obviously you can run SQL 2017 anywhere. You can run it on premises, you can run it in a VM, you can run it in Azure in a VM, you can run it in other cloud providers. So it gives you kind of the ability to run data everywhere. What's cool about Azure is we also then offer SQL Server as a service, and we call it our SQL database service. And this basically is the exact same code base as SQL 2017, and basically gives you the exact same feature set. The difference is we're running it for you, so we scale it out automatically across 3 servers or more for high availability. We're doing the backups and the restores and give you kind of what's called point-in-time recovery. So in fact, not only do we back up the data, but you can actually rewind the database to any transaction point and recreate it from that point. So if you accidentally make an app-level mistake and you start modifying or deleting data you didn't intend to, you can recover literally from the transaction before and continue. And this also does automatic patching and provides all this as an SLA along with a bunch of other great capabilities. Someone in my last talk asked me, hey, when is the SQL 2017 code going to be available as the service? And I actually told them the interesting little secret, which is the SQL 2017 code has actually been running our SQL database as a service for the last year. And we actually now build SQL first in the cloud because we have over 3 million databases running on top of it. And so we can actually really see how it's handling huge amounts of production load. And then for the release that we did on premises, we basically package up that code and deliver it on-prem. And that basically means SQL is now probably the most battle-hardened database code base out there, because by the time it ships on-prem, we already have 3 million databases that we've been running in production on it literally for months. And so that means, again, you get this great set of capabilities and you can run it anywhere. So let's go ahead and show off a couple of data demos here. First question I had was, how many people here, how long does it typically take when you ask your IT department for a new database? It's funny, everyone laughs, which is always a sign of longer than you'd like. And someone in one of the talks earlier this week was saying it took them 9 months. And I thought, you should get a new job, or a new employer at least. So let's go ahead and walk through what does this look like in a cloud world. And so I'm going to say new inside Azure, I'm going to say new SQL database. And so you can see that's an option here. And this is not a SQL database in a VM, this is a SQL database as a service. And so we'll call this Redshirt New York. I can choose where I want to run it in the world. So let's just run it here in North America, pin it to our dashboard and hit create. And so what this is doing is, just like you saw with the web app earlier, it is telling Azure through our management APIs, provision a new SQL database as a service, stand it up for me. This is going to deploy it on 3 servers, so I have high availability even if a server or disk storage goes down. It's going to wire up the right DNS. It's going to configure backup as well as point-in-time restore so that I have full backups and the ability to recover. It's encrypting the disk by default, so it's running TDE. And it is also basically plugging in all the monitoring infrastructure so that I can use that log analytics tool to query it, in addition to SQL Management Studio and the other tools that I'm used to managing SQL databases on-prem. And generally what this takes is about 60 to 90 seconds. And so it should just be finishing up shortly now, at which point I will have a fully ready production database that I can go ahead and use, and that we can start building applications against. And again, this is, yep, there it's done. And so, voila, I now have a new database, and it's ready to rock and roll. And that's now how easy it is to stand up a new database using Azure. And what's cool is they didn't have to buy anything, there's no license, and in fact, if you sign up for Azure as part of our free trial, we actually give you a 250 gig database of SQL now for free for an entire year. And the base version of SQL, I think it's $5 a month, is what a small database now costs. And you get all those capabilities I just mentioned. High availability, you get backups, you get point-in-time restore. That's all built into the service. And take this connection string, point SQL Management Studio at it, or point your development tool, or just use it in the browser, and you're good to go. And the other cool thing is when you're done, you can also easily delete it. And so let's say we no longer need this database, you just click the delete button. This is by far my favorite dialog box in Azure. I've been staring at this all week, and this is like, not only will we delete it, but it's going to hurt being when it's deleted. So it says, deleting it is irreversible. The action you're about to take can't be undone, in case you don't know what the word irreversible means. And then the best part is saying, going further, we'll delete it and all of its items in it permanently, in case you don't know what can't be undone means. And so, I have to compliment whoever on my team wrote the dialogue. The reason we have this is because, and I'll talk about it in the tips and tricks talk, is we unfortunately do have people that every day, often because they're distracted, think they're deleting their dev test system, and then they're deleting their production system. And so we'll talk about some tips and tricks in the afternoon about how you don't give everyone on your team access to the production database, and you lock down who can delete it. But anyway, so this one we no longer need. This one's now gone. We're not paying for it anymore. And hit delete, and it's completely wiped. So again, super easy way you can create something, super easy way you can delete it, and you can also scale it up and down based on the capacity you need. Let's look at some other cool features that are built into the service that you can leverage and differentiate it from other database offerings out there. Anyone here ever written code against a database that caused performance to be slow? A few, yeah. It's sort of like those production error bugs. Only a couple of us have had it happen, but or at least only a couple of people are raising their hand. But I think more might have experienced it. And so one of the things that obviously you can do today with an on-prem database is try to hook up a profiler and try to understand why the system is slow. But that often requires getting a DBA involved. It often requires you taking production sampling load. It's sometimes not the easiest thing to do. And one of the things that we've built into Azure now is the ability for us to automatically do that for you on a continuous basis, so that you don't actually have to wire up a profiler. Instead, you just click this performance recommendations tile that's on the page, on your resource. And what this will do is, this is actually looking at your historical load usage on your database of your real load and making recommendations based on what we see. And so this is an example of kind of taking AI and putting it directly into the product to make you even better and more successful. And so this is basically saying, hey, you're hitting this particular table in such a way that you could really benefit from an index that you don't currently have. And you can just click the view script, and we will show you the index that you should run. And this will basically index your table and make your app significantly faster. And you can either save the query, you can copy it to the clipboard, or there's also an apply button that you can actually just push directly in the portal, and we will automatically run that script for you against your database and significantly improve your performance. This is another tip here. We categorize the impact as high or low, depending on how much capability it'll help. This is around parameterized queries. What's cool about this one, you'll notice, is we actually will tell you how much CPU savings this particular query will give you. It'll actually save you 22.56%, and will decrease your average query time by 0.7 seconds if you apply this. And this is not sort of pseudo, this is actually looking at your real app and how the app is actually hitting the database. So this is actual real data that we can quantify for you. And again, we show you the script that you can apply, and you can either copy, paste, and put it as part of your SQL deployment script. You can run it manually, or you can go ahead and just click the apply button to run it directly in the portal. And if you want to, you can even go one step further and click the automate button. And any of these performance recommendations that we make, if we know that it's not going to be impactful or not going to require you to change your app code, you can click the automate, and we'll just automatically apply them to your database based on the actual load that we see. And this way you have a self-tuning database that will automatically optimize itself, again, based on the actual patterns that are hitting it, and enable you to constantly get better. So kind of some nice built-in features here that you can take advantage of from the performance perspective. Other things I didn't show, but that are super useful, is long-running queries. And so we'll also list, here are the top 5 queries that you're executing that take the longest and have the highest impact. And so you can also try to understand, can I cache it? Do I need to hit it on every request? Again, those are just surfaced automatically as part of this. The other kind of built-in feature that we have that I highly recommend you take advantage of is something called threat detection. Who here has ever had a SQL injection attack? Only 2 people, or 3 people. And then there's everyone else. How many people here know what a SQL injection attack is? Good. And if you don't know, please find out. We'll talk about it in a second. It's probably one of the most common security issues that people run into. And there's been lots of high-profile cases, even in the last month or two, where a SQL injection attack was one of the root causes of data getting out from a production system. And what's hard about a SQL injection attack is they're often difficult to know if you have, because they're not something that you can sort of lock down at the database level purely. A lot of it depends on how is the application calling the database. And so you can do pen testing on an app and think you're okay, and then someone accidentally checks in an update that exposes a SQL injection attack, and that one vector now suddenly exposes you. So let's walk through a simple SQL injection attack scenario. So I'm going to have a little login form for a sample CRM app. And I'm going to log in as Scott GU. And, timed out, let me do that again. So I'm going to log in as Scott GU. And one of the things you'll notice here is, oops, I got my password wrong. But it's okay, because this site has a SQL injection attack. So I don't need to know my password. And better yet, this site even has demo instructions on how to cause a SQL injection attack against it, which is truly awesome. You don't see that every day. And so this is sort of a little sample site someone built for me. And I love the fact that they literally have the instructions in line on how to do the SQL injection attack. But let's just kind of replay it for people that aren't familiar with how a SQL injection attack works. This is sort of an example of how I could do it. And this basically is relying on the fact that the app developer is taking the username that's posted and is manually concatenating it into a SQL statement. And so basically, as part of the login, it's going to say, hey, select from the users table, where ScottGU equals, or username equals ScottGU, and verify that the password is equal to the password that's being entered. And so what I'm doing here is something sneaky, because I'm assuming the person's manually concatenating the SQL string together. I'm adding a single quote at the end, which of course is going to close the SQL statement. I'm then adding an OR statement called 1 equals 1. You might say, well, why is that? Where the beauty is if I have a where statement where something username equals ScottGU or 1 equals 1, 1 equals 1 is always going to equal 1, which means that that where statement will always succeed. And then that last dash dash will comment out the actual where clause, which is doing the password check. And what that means now is if I click login, boom, I log in. And I'm logged in regardless of what username I specify. And now I have access to the data. And I can start to do even worse things. I could modify the data, because I could basically use that same technique to start doing updates or drop tables or exfiltrate data that I don't have access to. And now I suddenly have a data leak and I'm in real trouble. And so this happens literally every day, unfortunately, on the web across all systems. And it's something we all need to be careful of as developers. So one of the things that's nice about Azure, if you turn on this feature called threat detection, is as soon as I ran that demo, I got a mail that looks like this in my inbox, which basically says, we think there's a potential exploitation happening against your database because we've detected anomalous SQL activity that does not look normal, because that query is not a typical query that most people would see. And we basically deep link you into that particular experience and tell you exactly where it's coming from a threat protection. You can also configure this so that it will SMS you. We'll call a webhook. We'll plug into your ITSM system like ServiceNow. We will try everything we can, if you enter the right fields, for us to notify you, you really have a problem you got to deal with. And if you go into now your database, you'll notice there's a giant red thing at the bottom that's saying we have critical alerts that are firing on top of your database. And if you drill in here, you can basically walk through and see exactly details about it. And we'll even show you, in this case here, the audit log. Here was the actual SQL query that was executed. And again, you can see select star from users where username equals ScottGU or 1 equals 1. And then, boom, we pass the rest. And then just for kicks, this demo also stores passwords in clear text, which is even worse. So yeah, that's not good. So yeah, not good at all. But the good news is at least I now know that I have an issue, and I can basically take corrective action on it, hopefully before the bad guy has actually been able to modify the data or do something truly malicious with it. And again, I'll show you in the afternoon session how you can use our security center. You can basically integrate, if you're an enterprise, your existing security SIEM tools against our security APIs, and this would just show up immediately as an alert inside those. And like everything in Azure, this will basically trigger within 60 seconds from an alerting perspective of something happening. So you can basically catch it in real time and take corrective actions immediately and make sure you prioritize it. And again, it's just sort of a built-in feature you can use. And if at some point, either maliciously or accidentally, someone does modify your data or do something bad to the data, you can always restore a database, and this will create a new version of the database rewound to the point right before they did it that you can basically recover from. And obviously you don't have to do that often, but this is a nice safety catch to know that not only do you have backups, but you have point-in-time restore backups that you can rewind the clock to the transaction before something happened and restore from that point. So those are a couple of the features that are built in to the SQL database service. Lots more that you can take advantage of. Again, the nice thing is it's provided with an SLA. So we guarantee the uptime, we're doing the patching, we're doing the backups. And again, you can now use this and also have performance and security built in. Now the other thing, since a lot of people raise their hands about SQL, that they use SQL, that's nice, is because it is compatible with what's on premises, it makes it really easy for you to also migrate databases into the cloud. And we're doing two things in particular that'll ship next month and you can start taking advantage of to make that even easier. One is a set of updates that we're doing to our SQL database service, where we're adding basically the feature set that's on-prem that we don't yet have, that are some of the more advanced or esoteric features, so things like SQL agents, or things like Service Broker, or CLR stored procs, or SSIS, migration service custom scripts. Previously, we didn't support that with our SQL database as a service offering. Now we're having a new thing we call managed instances, which basically give you the 100% full feature set of SQL Server. The other thing that we're then shipping next month is a new migration service that helps automatically take your existing databases and migrate them to the cloud with basically zero downtime. And it'll even do, for very large databases, it can transfer the data, and then while your existing system is running, and even then basically do a top-up of any change since the migration started, and then you can cut over really quickly to the cloud with almost no downtime for your application. And the combination of those two things makes it incredibly easy to basically migrate anything that's running in SQL to the cloud, super cost effectively, and hopefully without ever changing a single line of code. And what I'm going to do is invite Scott Kata here on stage to actually show off that SQL Managed Instance support with a real app, in this case here, Stack Overflow, which is an app a lot of people here probably used. They have an enterprise edition that you can run on premises that uses SQL 2008 today. And I think what Scott's going to show you is literally taking a live database with 700 megabytes of data and actually migrating it from your laptop up into the cloud.
In about 30 seconds.
Cool.
It's really fast. So what I have on my machine here is the Stack Overflow Enterprise app that Scott's mentioned. And the goal is to migrate our app to the cloud without changing any code. So what I'm going to do is simply change the connection string. Now, if you had this connection string coming from Key Vault or something else, you could change that in another fashion. But this is a pretty good demo. So I'll just press F5 to run. It's going to take about 10 seconds to pop up, and you'll see the Stack Overflow interface is running. Now, I've got a stored procedure that tells me the version of SQL Server that's running. What I've done is I've taken that and put it into the output with my CSS skills at the bottom of the screen, so it's very big and large and easy to see. So currently we're running SQL Server 2008 R2. This particular database has something unique that's currently not supported in SQL Azure, which is cross-database joins. So if you have two databases that talk to each other, that will now be available for you in SQL managed instances. Now, one thing to remember is that this is not a VM. You could actually solve these problems today on your own by hosting your own SQL Server in a VM inside Azure. Then you have full capabilities, which is a common workaround today. But now managed instance as a service will actually do all of this for you. So let's go ahead and close this. I have got the portal open, and I've gone ahead and put in my connection strings for both my target, which is the managed instance that's already created for us. There's no databases in it, but my target is there, so I have a connection string. So you can see if I simply click Save here, it'll take me to step 2. That's going to then ask me for my source. So this is the on-prem database. And if you look at my source here, you'll see the connection string is going to tie back to Redmond. And I'll just zoom in here. And so this is my on-prem database. Happens to be inside Microsoft, but it's not inside of Azure. I've already got my connection string here set up, so we'll change that to SQL authentication. We'll zoom back out and simply click Save. Next thing it's going to ask me is, here's the source database that we've interrogated, or the database. Which one do you want to bring forward? In this case, these are the two enterprise editions. Simply click Save. Now it's going to ask me, where can I temporarily store this backup? Because what happens, just like when you make a backup, you end up with a BAK file. And so the migration service needs to store that somewhere and then read it and pop it back in for our restoration. So these are my network credentials. Again, I've already populated that. It's going to give me a nice summary screen that I can double check everything is correct. And then this is going to take somewhere between 30 and 60 seconds as I click Run Migration. So go ahead and do that. And while this is working, we will jump back over to Visual Studio. And I'll just show you at the bottom of this layout page, I have a footer file. And inside the footer file, or the footer section rather, we're modifying this, or outputting rather. There's my mad CSS skills. Model.SQL Server. And then inside the controller here, I'm simply executing that stored procedure. So let's go back and change our connection string, right? So we have Control K C to comment, down, down, Control K U to uncomment, Control S to save. And before we run, let's jump back over to the migration assistant. We'll click refresh. That looks like it's succeeded. Let's just take a peek at what it did. So in 16 seconds and 18 seconds, so 34 seconds there, I've got a 372 megabyte database converted, another 486 meg, and the cross database joins were smart enough to rewrite themselves along the way. So now if I jump back over to Visual Studio, simply press F5 to run. Again, this takes the 10 seconds or so to compile and start up. And as we migrate now to the bottom of this form, we should see that we are in fact running in our new managed instance with SQL Server. And there we are, 34 seconds. Perfect, thank you, Scott.
Cool, thanks. Yeah, so the cool thing there is just how easy it is to migrate. And again, the goal is 100% compatibility with all the feature sets you have. So whether it's cross-database joins, SQL CLR proc, service broker, SSIS, custom migration scripts, you name it, they work with this new system. And the benefit is, you're not moving it to a VM, you're moving it to as a service. So the profiling stuff I showed, the SQL threat intelligence stuff I showed, the automatic backup and restore and SLA capabilities I showed, you get all that, which dramatically lowers your TCO. The other thing that you can do is you can take your existing SQL licenses and not only just use them inside Azure, inside VMs, but you can also use them with the as a service option with this managed instance. And so you don't actually have to pay for SQL again. You can now use it as a service and basically reuse the licenses that you already did. And the thing I always love to tell people is you can never run a Windows or SQL workload more cost effectively in any other cloud than Azure. And with the licensing options and with the TCO and the service options, it will always be less expensive in Azure in order to run. The other thing I'll just mention, even though it's not a database specific, but it's one of these tips and tricks that a lot of people don't know about, that works just for VMs as well, is when you create a new VM in Azure, let's say you create a Windows VM or SQL VM, we have this as well. If you scroll down, we have this nifty feature called Save Money. And we used to call this the Azure Hybrid Use Rights Benefit, and no one clicked it. And then we changed it to be Save Money, and then lots of people click it. And it's the same thing. And so basically what this lets you do is, if you already have Windows Server licenses, which if you're in an organization or enterprise, you almost certainly do, you don't have to rebuy them when you come to the cloud. Whereas if you go and use standard Amazon or standard Azure, you're paying again for that license, and it's included as part of your cost. Instead, you can just sort of basically say, I already have a license, click yes. All you need to do is just confirm that you really do have a license, and then go. And that drops your price by 40%. And that's something that's only available in Azure. No other cloud provider delivers. And the combination of this plus, say, a reserved instance can drop your price by over 72% off of what your standard rate would be. And again, there is no other more cost-effective way to run a Windows Server license in the cloud than that. And there's no more cost-effective way than Azure to run your SQL instances as well. So definitely worth checking out. It can save you a lot of money as you take advantage of that. Yes, the question is, what if you use PaaS? So for example, let's say you use the SQL DB as a service. Do you get that discount as well if you already have a SQL license? Yep, you would. For Windows, depends on the service. Some services, yes, some services, no. In general, we're trying to make it available for everything. In some cases, like with serverless, it's hard to know like how many servers are actually running, so there isn't a direct apples to apples comparison. But if you use like a VM scale set to run Windows Server licenses, it would apply. App Service doesn't, because we don't expose the VM directly to you. but for like VM scale sets would, raw VMs would, and I believe container service would as well. Just because that's where we expose the VM a little bit more, and so it's easier to apply. So anyway, so something to check out. The new managed instance work as well as the migration service will be in public preview for everyone to use in the next 4 weeks. And so definitely check it out once it's there. We've talked to a lot of large enterprises, including a few that were very early in Amazon 6 or 7 years ago, and run a lot of capabilities in Amazon. But they've had this problem of they've got 10,000 internal apps, and migrating them and doing database modifications on those 10,000 apps was something they just said, this is going to take on average a couple weeks per app to do all the testing and certification. And they set up using the preview, the private preview of this migration service and database as a service. And they're now moving wholesale apps fully tested within 4 hours to the cloud. And they said it's been a game changer for them because they're now able to really move things without having to do massive modifications and get much better reliability and TCO at the output. DocuSign's another great example of a enterprise SaaS startup that also is moving heavily to Azure as their cloud provider. They run an on-prem data centers today, and they just announced earlier this year that they're moving. And this SQL database as a service was a game changer for them because it basically allowed them to reuse their heavy SQL workloads now as a service. I don't know if DB01, anyone from DB01 here? I know they're based in New York. No? And they're another financial services startup that's based near here. They were also in my keynote at Ignite last month as another great example of people taking advantage of it. And then for people that don't use SQL, don't worry, we got lots of options for you too. And so specifically, we have not just SQL as a service, but we also now have Postgres and MySQL as a service as well. And this gives you kind of the same style capability where we deliver it as a service with an SLA. We do the backup and the point-in-time restore for you automatically, and basically give you, the database of your choice, again, as a fully managed capability to enable you to kind of move even faster. And what's nice is from a tooling perspective, this just looks like a Postgres or MySQL database. And so you can point existing apps, existing drivers, existing frameworks at it, as well as existing tools. And it just looks like Postgres or MySQL. So let's go ahead and if we can switch to the Mac, I'll show you a quick demo of Postgres. And so what I have here is Postgres as a service instance deployed. And so creating a new one of these is really easy. You just go ahead and click New. And then on Databases, there is the Postgres option there. And then once you create it, you can launch this. And this basically gives you, again, sort of a resource monitoring view. You can look at your databases. You can do the restore option, just like you can do with SQL, I mentioned, the point-in-time restore, and so forth. And again, it's the same Postgres and MySQL engine, so all the same query and code that you're used to should work. This is an example of the PG admin tool, which is one of the popular Postgres GUI-based tools. This is running my Mac. I'm pointing to that Postgres as a service database inside Azure. And you can see all the standard monitoring and telemetry information is output just like you'd expect. As far as this tool is considered, this is like just talking to a Postgres database on a bare metal server or inside a VM. But now it's as a service where we're doing a lot of the heavy lifting for you. So easy way you can take advantage of your database of choice. So we switch back now to the PC. Let's talk about some other data options that we have and how you can take advantage of them. You know, I think one of the things that I get really excited about with the cloud and with Azure is the ability to not just sort of take your existing apps and run them, but really build new apps that just weren't possible before. And when you think about 42 regions around the world that you can deploy your code into, that means you can build apps that literally have billions of people that are actually accessing them on a daily basis. When you think about things like IoT, or think about mobile apps, or think about sensor devices, or augmented reality capabilities that are coming out, you're also going to be generating more data and more input points probably than ever before. And so the other trick that you got to think about is if you have billions of people all generating billions of points of telemetry, how do you handle that data and how do you handle it at scale? And it brings with it unique requirements. And one of the things that we launched earlier this year that we're particularly excited about and seeing amazing growth in is our Azure Cosmos DB database. And this is what we call the first globally distributed multi-model database service. And it enables you to build these types of next generation apps. Let me walk through a couple examples. So what's nice about a globally distributed database is it isn't just running in a single region. Instead, you can actually deploy this Cosmos DB instance in multiple regions around the world inside Azure. And so you could have, say, one on the East Coast and West Coast of the US. You could have one in South America. You have one in Europe. You could have one in Australia, one in Asia. And times that to another 36 around the world if you wanted to, and pull them in all 42 regions. And what that means is when you write a transaction, it is going to replicate automatically to all those regions, and that you can basically read from any of those regions on any of the data that's stored inside your Cosmos DB. And that's important because one of the truisms is you can't go faster than the speed of light when you're writing an application. And so if you've got a customer in Australia and your database is in the US, it is going to take, no matter what you do, no matter what code you write it in, at least 300 or 400 milliseconds for you to go to the US and back, because that is what the speed of light would take on a wire to be able to send any signal. And so if you can instead have the customer in Australia hit a database in Australia, you can instead return that in milliseconds. And one of the things that Cosmos DB does is guarantees that any read that you do against it will complete in under 10 milliseconds. And so that can literally be lightning fast and exponentially better. Now what's nice about Cosmos DB is it also allows you to store data in a variety of formats. So you could do tabular data or more like traditional relational data. You can do key value pairs. You can store documents. You can do columns. And you can also do graph databases. And so you can start to also pick what is the right data model for your particular application and use it appropriately. You can also then use whatever API you want against it. So you can use MongoDB if you're coming from, say, a Node background, and you just point your MongoDB driver and existing frameworks against Cosmos, and as far as your app is concerned, it's talking to Mongo, but under the covers, it's actually using Cosmos DB. You can use Spark if you want to do analytics, or you could use Gremlin if you want to do a graph API. And we obviously have table and document APIs as well. And so this gives you, again, more flexibility as you're building your apps to choose what is the best API, what is the best data model for your scenario, and deal with it. And then what's really cool about Cosmos is it scales to pretty much any need. You can start with just a few gigabytes of data, but you can also then configure it to store 5 or 6 petabytes, where a petabyte's 1,000 terabytes of data. You can start with just, say, 400 transactions per second, but you can also flip the dial and say, I want 4 million transactions per second, and it will scale to that size. And what's great is for all these things, they come with a money-back SLA. And so we don't just say, hey, you could theoretically do 4 million transactions per second. If you provision it for 4 million transactions per second, we will guarantee 4 million transactions per second at the 99th percentile, or you get your money back. Similarly, we provide guarantees around performance latency. And so when you're doing that 4 million transactions per second, we guarantee that each of the read operations will complete in 9 milliseconds or less, or you get your money back. And that gives you kind of an ability to build systems that are massive scale and actually know that they're going to work when you throw tremendous load at them. Jet.com, which is now part of Walmart, was a startup that got started on Azure, and then they were bought by Walmart for a couple $2 billion. And they now drive a lot of the e-commerce work at Walmart. And I think I don't know if anyone here's from Jet. They're also got a team based here in New York. But they basically distribute their application across 3 US regions today. So they have one on the East Coast, one in the Central, one on the West Coast. And this way, when someone here in New York visits Jet.com, they're hitting the East Coast region. If someone in San Francisco types Jet.com, they hit the West Coast region. And so it's very, very fast for someone to hit the site. And they then have Cosmos DB deployed in those 3 regions as well, so that the app is talking to a database that's also right next door. They scale up Cosmos DB to a massive level. Last Black Friday, they provisioned it for 100 trillion transactions that day. I actually thought that was a typo, because that's a lot of zeros. But it actually, they provisioned for 100 trillion transactions, and they saw single-digit performance latency at the 99th percentile. So they met their SLA the whole day. No other database out there will give you this type of performance and load. And what's cool is it's really fun to program against, and if you sign up for an Azure free trial, you actually get a Cosmos DB database for an entire year. So you can actually experiment with it and build some cool stuff. And what I'm going to do here is, if we can switch back to the Mac, is walk through building a simple app here and show you how to do it. So I'm going to launch, in this case here, it's a Node app, and I'll load it here. This is sort of a simple Wikipedia app, except it's a Wikipedia for Marvel comic characters. Anyone here like Marvel? Yes, great. It works well in a developer setting. It doesn't work as well in a financial analyst setting, but fine. Developer talks, it's great. So, this is a simple Wikipedia, so there's lots of content about the characters. And then what we've done is just implemented a chatbot. And so if I want to ask questions, so who are your friends? This is to Tony Stark. Brings back the list of friends based on what's stored. If I want to ask, for example, who are your enemies that work for Hydra? Hit enter, brings it back. So I can ask, interactive questions effectively of Tony Stark and have kind of a fun app that works. Now, the interesting thing about a site like this is, you can imagine, what if we start adding, friends, and you can also like people and et cetera inside here is, what is the best data model to store, to build an app like this? It's probably not a relational database. Because you've got lots of characters in the Marvel universe, you might have lots of friends on the social media site, and a graph database might actually be a much better data representation for a lot of these queries. Because if I want to say, who are your enemies that work for Hydra, I'm now starting to actually do interesting joins and traversals that sometimes aren't easy to express in a relational way or aren't performant to express. And if I start wanting to see, who do I like that my other friend likes, again, it's much easier to traverse that in a graph than it is as a traditional foreign key primary key pair. So the cool thing about Cosmos is it makes it easy to stand up graph databases. So I can go ahead here and just say new database. There's Cosmos DB. Click it, and then I can basically name the database just like we had before. And I can also choose what's my default API that I want to use against it. And you'll see there's this gremlin graph option, which is the third down, that I can go ahead and select. And then I can basically choose where I initially want to deploy it, hit create, and in a few minutes I'll have this sort of Cosmos DB system running. Here's one that I have created earlier that already has some data populated in it. And this has a number of different graphs. And so for example, here, I can drill into the heroes database or collection inside here. And this is bringing back a sort of an experience here that I can run inside the browser. So for example, if I want to pull back, let me increase this a little bit so you can see it better. Here is, for example, the data that is represented across some of the Marvel character universe. Now, right now we have GUIDs for each of the records. One of the things you can do is click Style, and you can actually control, let's show the name field instead. And so this will make a little bit more sense now. You can basically see how all these different characters interact, and you can kind of see that there's, again, a graph where each of them, in turn, have relationships to others. And this kind of gives, a nice little simple way you can visualize it. Now, what's nice is I can basically type whatever custom query I want, and I'm actually using this gremlin syntax here to specify what is the graph query I want to retrieve. And so g.v. is the gremlin syntax for doing a graph query against this particular data source. And it has its own syntax that I could use to filter, sort, and bring back different objects. And what's nice is I can program that using any standard Gremlin API. And so, for example, if I launch VS Code here, you can see this is my Node.js app. I've just imported the Gremlin NPS package. So this is Node using TypeScript as language. And then you can sort of see here G-V, the hero ID, and I'm pulling back the path. If I go ahead here and go to the definition and map relations, you can start to see how some of the relation and predicates are constructed. And this is just standard JavaScript library for Gremlin. So I could use whatever, I could have a .NET or Java version of this as well to be able to code against. So a really easy way now, I can store my graph build my database as a graph. I can program it using a standard graph API. And then the other thing I can do is, because this is Cosmos, I can now run this and store this data everywhere. And so if I click on replicate data globally, you can see all the different Azure regions out there. And if I want to, I can select and choose to deploy this database anywhere else. If I want to deploy it in Brazil, I could click Brazil. If I want to deploy this in Hong Kong, I could click East Asia. If I want to deploy this in Korea, I can click that. And then I just have to hit save, and then this will automatically deploy that data into a Cosmos DB instance in that region. And then my app in that region can just access it locally, and again, get guaranteed performance of single-digit millisecond response time against any of these graph queries that I might throw against it. And that now suddenly enables me to take this app and really make it global. Now, one of the challenges that you have in any type of distributed system, and this is true even in your own data centers, but this becomes very true when you're operating around the world, is that truism of you can only go as fast as the speed of light. And so if I want to write my transaction here in the East Coast of the US, and I want to have the data show up in Australia, there's a question, which is, when I write the transaction, when should the transaction complete? And that basically comes into the consistency model that you want out of your database. And for a lot of us, we're used to talking to one database server, and so it completes as soon as it writes to that local server. But in this world here, there's a couple different options I might want to have. I might not want to wait to complete the transaction until it's written in Korea or Australia, because that might take a second to go back and forth around the globe to commit it. I might want to do what's called eventual consistency, where Cosmos completes the transaction immediately as soon as it's saved locally into one region, and then will automatically guarantee that it replicates it to the other regions asynchronously in a certain period of time. And the nice thing is, Cosmos gives you that flexibility. And so if you click on the consistency models, here, you can actually choose to run the database in an eventual consistency way. You can also run it in strong consistency, which basically says, nope, when you write the transaction, don't complete it until everything sees the result in every region. And you can choose to do it that way as well if you want to. We also have a pretty cool feature called session consistency, which is actually probably the most common way that we see people typically use it. And this is nice in the sense of it basically guarantees that if I write a transaction and then immediately read, I will always see the results that I just wrote. So I always see a consistent experience. So if someone's in a shopping cart, they'll always see their shopping cart consistently. But someone in Australia that's reading and writing different bits of data won't necessarily see it until it eventually becomes consistent, but they'll make sure that they always see a consistent version of what they read and write. And that gives you kind of a nice trade-off of, you don't have a weird experience if someone hits refresh, but at the same time, it's lightning fast for when transactions write. So you can choose any of these consistency models with Cosmos, and so you can choose whatever works best for your application. You can set it the default, so this is the blade where you set the default consistency, but you can also go ahead and override it on a per transaction basis. And so you can even within your application choose for different scenarios, what happens immediately, what happens with eventual consistency, what happens with strong consistency. So for example, for this site, the content, eventual consistency probably is more than good enough. For any likes I might do, session consistency is probably what I want to have, because I want to make sure if I like something and then suddenly go to Australia simultaneously, I will still see my like. And if I put in my credit card and I place a transaction, I might want to have strong consistency, because I want to make sure as the app developer that if I've told the person they've paid, it's done and written consistently everywhere from a financial perspective. And again, the good news is Cosmos gives me that ability to do all three of those inside the same app and inside the same database. And then last but not least, The cool thing about Cosmos is everything that you configure from a capacity perspective can be tracked with our metrics view. And we basically will tell you whether we're meeting the SLA and actually show it. And I have the problem, which is I've got only one request that's hit the site, so there's not, or two, I guess. So there's not a tremendous amount of load going against this. But this will actually tell you, this is what you provisioned for, and this is how much you've used. So I have a little bit more opportunity to fully use this database. But this will actually show you if you're ever trying to use more than what you provision. And this will basically tell you if, for any reason, we weren't able to actually deliver it. But the SLA basically guarantees at the 99th percentile, both from a capacity and latency perspective, that will always meet what you provision. And again, that gives you sort of the ability to build these massive apps and have them run really reliably and at scale. So that's a little bit about Cosmos DB. It's generally available now, and you can take advantage of this, again, to build some pretty amazing systems. So let's go ahead and go back to the PC now. Talk about a few more things. So how many people here are using containers today? Okay, a number of people are. How many people have heard of containers? Great. How many people have never deployed a container? Okay, we're going to solve that problem right now. We're going to deploy our first container together before lunch and walk through a couple of different ways that you can use containers inside Azure. So, I mean, we're pretty excited about containers. So we're leaning in very heavily on containers across Microsoft and across Azure. You heard me talk about how SQL 2017 can now run in a container, which makes it super easy to deploy and super fast to deploy anywhere. And we basically are updating all of our platform services in Azure where you can deploy code to be able to use containers. And so we have a container service that runs all of the different popular open source container orchestration frameworks. So we have a great Kubernetes service, Mesos, Docker Swarm. We have a higher level microservice framework that we call Service Fabric that supports standard Docker containers as well. And this provides not just orchestration, but also provides a bunch of rich data services and consistency capabilities that go above and beyond core orchestration. And then you can also just take a web app like the one we created with App Services this morning and deploy a Docker container to it as well. We also then have a batch service that allows you to kind of run background batch tasks as a service. And again, you can just supply us with a Docker instance or Docker image, and we'll run it and scale it potentially over up to 1 million different servers, depending on the load that you want to put through it. So the great thing is you can use containers everywhere. We also just launched recently a new service in Azure we call our Azure Container Instance. This provides the sort of the simplest and fastest way to get a container up in the cloud of any cloud provider. And basically with a single command, you can provision any Docker image, whether it's Windows or Linux based, launches in seconds, and you literally pay only for the seconds that you run it at. And since some people have never deployed a Docker container before, let's go ahead and do one together and show what it looks like. So I'm going to go ahead and launch the bash shell here, again, inside the Azure portal. I can run this locally. I could use this with PowerShell as well, but this is sort of a simple way that we can just sort of type it and literally see deploying a container together. We also have it so you can do it through the web GUI as well, but I think it's sort of more fun to do it through the command line in this case. And just so you don't have to watch me type it all while it's loading, let me just grab this command here so I don't have to type it. So what I'm going to do here is launch a new container instance. And to do that, I am going to run this command. So let's go look at this command. And this is basically, again, using the AZ command line tool that we have in Bash. It's going to say AZ container create. And so the syntax in Azure is you type AZ and then the resource type and then the verb. So AZ web app create, we create a web app. AZ container create creates a container instance. And then basically I'm just going to give this name Nginx1, and then I'm going to give it a pointer to a Docker image, and in this case here I'm going to do library/Nginx. This library image can be hosted in Docker Hub, which is sort of the public repository for Docker images, or it can be pulled from a private container registry that you can provide, that you can create and run inside Azure itself. And so typically what we find is people pull from Docker Hub for a lot of the standard images, and then they store their app images in the container registry, which is locked down just for them. And then all I need to do is give it a resource group name, and I'm just going to specify that I want a public IP address, since this image here I'm pointing to is Nginx, which is a web server. And now I hit enter. This basically calls out to Azure. Azure just said, got it, I'm now creating this. And so the provisioning state on this guy is called creating. So it's spinning it up. And if I want to now check the status, I can go AZ container list. And I'm just going to type in the name that we created it, red shirt, ACI, oops. And I'm just going to output it as a table so we can see it. And if I zoom in here, you'll notice there's Nginx. It was succeeded, meaning it's running. And here's the port it's running. I'm going to right click and go to it. And what we should see here in just a few seconds is Nginx spinning up for the first time inside this container instance. Let me just make sure I get that again. Oh, come on. It's weird. It's getting a firewall proxy, which makes me wonder if there's something on the network here. Come on. Come on. There we go, and there it is. So I don't know why it took a little while. Maybe there's a firewall proxy between me and the internet on this network, but you can basically see this is that Nginx image running at that IP address. This is just the standard Nginx image, got pulled from Docker Hub and deployed inside Azure. And I now have a Docker instance up and running. And I'm paying for it by the second. And if I ever want to shut it down, I can just say AZ container delete. And I'm just going to give it the name. And if I spell the name right, it'll work even better. Are you sure you want to delete it? Yep, let's delete it. And it just tore it down. And so that's the simplest way to basically create a container and delete one, all in the matter of about a minute or two. And again, this works for Linux containers. It also works for Windows containers. And so you can literally upload any type of container you want and go to town with it and run anything you want within it. So this core underlying container capability, gives you a lot of flexibility. And then again, these higher level platform services we're building takes advantage of it and gives you a nice programming model. So let's go ahead, and since there's lots of .NET developers and VS developers here in the audience, let's actually, how many people here have actually containerized a .NET app? A few. Let's all go containerize a .NET app before lunch. Then we'll look at serverless, and then we'll do lunch. So what I'm going to do here is just create a new project from scratch. I'm going to use .NET Core, although I could use full .NET Framework. But I'm just going to use .NET Core here. We're going to create an ASP.NET Core app. And we'll just create the default MVC template. And right now, this is not Dockerized. There is an option you can Dockerize actually as part of Project Create, but this is just using vanilla non-Dockerized as an option for right now. And I could obviously hit F5, and this would just run as a Windows app on my local dev machine. But what I want to do is I want to Dockerize this thing instead and use Docker as sort of the container format. And to do that, I'm just going to right-click, and I'm going to say Add New Docker Support, which is the new option that Visual Studio supports. I'm going to click Yes. Now, because this is a .NET Core app, VS is then going to ask me, well, do you want to Dockerize this on Windows and use the built-in Windows container capability? Or do you want to Dockerize this as a Linux image and run this on Linux hosts? And because it's .NET Core, and .NET Core runs on both Windows and Linux, I can do it in both places. If it was a full .NET Framework app, I could only do it in Windows. But since this is .NET Core, and just it makes for a better demo, I'm going to click on Linux, since it might be something you haven't seen before. This just added a Docker file into my project, and it's a standard Docker file format. And so it's just saying, here's the image, and here's the entry point for this application. And I'm now going to click the Docker command here inside VS, And this is now going to build the project, and then it's also going to Dockerize it as a standard Docker image, and then it's going to run it using the local Docker instance that's installed on my PC, so Docker for Windows. And I will warn you, I did an update for Docker for Windows earlier this week, and I'm on some experimental branch, and it is slightly more finicky than the previous version. And so that is not Visual Studio or Azure. If you see a weird Docker exception, that is Docker itself. But anyway, this worked. And what you can see here is, like you'd expect your ASP.NET Core app, but here's the cool thing. This is ASP.NET Core running in Docker, running in Linux. And so this actually spun up a Debian Linux instance on my PC using our hypervisor, Hyper-V, on my laptop. And so this is actually running in Linux, in Docker, on this PC. And if I go in, instead of breakpoint, say in the About thing, I can actually click About. I'm now broken in the debugger inside Visual Studio, and I have full watch window, full breakpoint, traversal support, debugging a Linux app running .NET Core in Docker, all interactive inside the IDE, which I think is kind of cool. But wait, there's more. So let's go one step further and now take this Docker app that we just built and are running on Linux, and let's deploy it into the cloud and run it inside Azure. And so cool thing you can do is I could set up a CI/CD pipeline like we did before the break. I can also just, for my first time around, let me just go right-click and hit Publish. And because this is a .NET Core app that's Dockerized for Linux, I have the option not just of deploying to an Azure App Service, but I can also use the Azure App Service Linux option, which natively supports Docker as well. So I'm going to select that, hit Publish. This is going to give me another little dialog here, similar to what you saw earlier with the app service, where I can go ahead and create resources, and I can give it a new app name, so it's just giving me a random name. I can change that to be whatever I want. One thing that's different here versus the standard app service dialog is it's also asking me for, oops, I clicked the right thing, for a container registry. And so container registry is basically a way that I can deploy Docker images into that only I have access to. And that's actually going to be what the app service pulls the application from. And so if you don't have one, it'll either automatically create one for you or allow you to select it. I do have one, so I'm just going to use that. And I'm just going to hit Create. And this is now going ahead and provisioning a new Linux-based web app in East US, which is the region I specified. It's now going to compile and then push that Docker instance up into that registry, point the app service at it, and then once this is all completed, this brand new ASP.NET project that we created will be running in a container, in a Linux instance, in an Azure app service, all end-to-end running in the cloud. And so this is doing the first time creating the app. It's now going to go ahead and build this locally. And then the other thing you'll see at some point is the docker.exe command will pop up on my IDE, and you'll actually see the standard Docker protocol pushing this container instance into the registry. And so you should see it in just a second, hopefully. This thing will pop up. There you go. And it's pushing the image. Now, the cool thing here you might notice is it only had to push 3 megabytes, and that's because it only pushed the app-level image. Azure already had a .NET Core Docker instance and already had the Debian instance already inside the registry, and so it didn't have to pull that. And then basically on the app service level, Docker is going to combine that and merge it and compose those images to run my application. And so now if I go here, oops, here's the URL, let me click it, and I should see in about 5, 4, 3, 2, 1. There you go. This is now running. Yeah. And so this is, again, a .NET Core app running in Linux, Dockerized in a brand new Azure app service from scratch. I can use the same deployment slot features we talked about earlier. I can use auto scale. I can do all of the logging capabilities that I showed earlier and all the log analytics support. Someone was asking me earlier this week, well, let's say I have a Rails app and I'm running it inside this Docker instance. Is there any way I can take the Rails HTTP logs and have it show up inside Azure? The cool thing is all you need to do inside your container is just pump the logs out to standard output, and then the Azure App Service will collect it and shoot it into the standard Azure log entry stuff, and then you can write those interactive queries immediately against all that telemetry. So again, super powerful way you can literally deploy and Dockerize any application and now run it in the cloud in a super cool way. So, last thing we're going to do before we break for lunch is talk about serverless computing. How many people here are doing serverless computing today? Cool. How many people here have heard of serverless computing? Great. It's one of those buzzwords that I think everyone's talking about because it's a pretty cool technology and it's a pretty cool approach. And we got some great ways to do it inside Azure. And so the idea behind serverless is, rather than create, say, an app service instance that I need to deploy an app into, for certain types of workloads, wouldn't it be cool if I don't have any infrastructure that's running all the time, and instead I can just deploy the infrastructure for a few milliseconds, run some code, and only pay for the milliseconds that that code is running. And that's kind of basically the idea behind serverless, sort of at a high level. And within Azure, we got a bunch of ways that you can do that. You can run code in response to HTTP web requests, in response to timer changes. So you can say run this code every 10 minutes or every 5 seconds. You can run it in response to a storage file being uploaded inside the Azure storage system, or a queue message being added to a queue, or even things like a CRM record getting added to Salesforce or Dynamics, or a list changing inside SharePoint. And one of the easy ways you can use it is with something called Azure Functions, which is an app type that we have in Azure specifically designed for serverless. It lets you use any language you want. You can develop it in the browser, but you can also develop it on your Mac or your PC. And we also have a runtime environment that does debugging and development locally. And you can obviously wire it up for CI/CD as well. So let's go ahead and look at some functions and build a few simple functions and show it off. And so this is actually a project I have in Europe, so it takes us a few extra seconds for the thing to load because it's pulling all the data from Europe. But basically what I'm going to show you here is the function app module running inside the Azure portal. And this gives you kind of a nice interactive way that you can do function development without having to have any tool at all. And so you can actually literally code in the browser if you want to and do it. So let's create a new function. We give you a bunch of templates. I'm going to use this HTTP trigger template to get started. This sort of a good hello world template. And so we'll just click that. And then we will name this New York, or how about hello New York? How about that? Hello New York, HTTP, or just so I know what it is. Hit create, and this is going to, by default, create for me, in this case, because I selected C#, a simple C# function. I could do Java, I could do JavaScript, I could do F#, I could do whatever language I want. And so I got a simple function here, and there's no project, there's no class. This is like literally the function that I want to have execute. And right now, all it's doing is pulling a value off the query string and then spitting it back out as a response. So very simple hello world. And if I hit run, we even have sort of an interactive streaming log thing that'll show up in the browser so I can easily test it. I can click get function URL to basically copy the URL of this function. And if I hit it now in the browser, it says please pass a value. I could go ahead and hit name equals New York. And now I spat back hello New York. So simple way there that I literally just, we don't need that, we don't need that. I literally was able to build a simple function that just responded back with some input and get it deployed. Now the beauty is I'm only paying for the milliseconds of execution that this function is running. So I don't always have this thing running. This particular request costs like 1/1,000,000th of a penny. And so really provides a really cost-effective way if I just have an infrequently used thing that I can go ahead and run. We even, because it's running, it scales out dynamically, it can also scale to be millions of invocations per second. And so we have like one customer of ours I like to joke about, and they do 1 billion of these per day, 1 billion function invocations per day. And they came to us after the first month and said, you got a bug in your billing system because it's coming back as $72. And we said, oh my gosh, we must have a bug in our billing system because it says $72. We checked, it wasn't a bug. They said, yay. We said, eh. And again, because they're only paying for the milliseconds that's running, it ends up being incredibly cost effective. Let's create some other stuff. So here uses GitHub. A lot of people. Who here has ever wired up a webhook from GitHub? A couple people, great, okay. Not as many though, so let's go ahead and walk through how you could wire up a webhook from GitHub. So in GitHub, and this is true for VSTS as well, in pretty much all sites now, is there's ways that you can effectively get notified in response to things happening, and they're called webhooks. And basically, the way this works is you can go into GitHub and say, I'm going to add a webhook, and you basically specify to GitHub what is a URL that you want them to call in response to something. You can tell them, do you want it in JSON or just a form? You got to pass in a secret that they give you so that you know that this is GitHub and not something else. And then at GitHub, what you can do is you can go ahead and say, what do you want to actually fire an event in response for? And so you could say, like, when a new issue comes in, fire off a webhook, or a new member or a new fork, fire off a webhook, and that way you can choose to write code in a different, in response to it. So it's a simple way you can go ahead and wire up webhooks, and you can do this from SharePoint, you can do this from VSTS, you can do this from Azure, so you can basically integrate webhooks from anywhere. And what we have inside functions is the ability to very easily wire up a GitHub webhook. And so we even have a template here that you can specify down here called GitHub webhook. And here's one that I've already wired up. When you do GitHub webhook, we give you the function and you even get the secret. And so you just copy and paste that into those two values into that GitHub UI. And this default template right now is just, again, 4 or 5 lines of code. It's just outputting whatever GitHub sends us. And so if I hit run now, and then go into GitHub, let's say I create a new issue, and we could say something happening in New York. Hit comment, posted this into GitHub. GitHub fired the webhook to Azure. And if you come here and now zoom into the log file inside Azure, notice that value was just passed by GitHub to Azure, my function invoked, and I just output it to my output log inside those 4 lines of code. And so now, simple way I can basically use functions, not have to have a process sitting around just waiting for someone to call it. Instead, I can very easily use this for glue code across my systems and execute only on demand. And so if you've got a really popular GitHub repo and you hit thousands of issues and thousands of pull requests happening every day, wire up an Azure function, and you'll probably pay about 4 cents a month to run code in response to it. And ends up being a super effective way, again, that you can do stuff. Another example I'll show real quick is blob trigger. So within Azure, we have a mechanism we call our Azure storage system, where you can basically upload blobs, which can be any arbitrary file of any size. So you can have storage accounts now, I think by default, 4 petabytes is the size. So you can literally upload a lot of content in them. This is a storage explorer, which basically is a nice GUI that you can download that runs on any platform. Let's say, hello, New York. Lunch is soon. And so I'm just going to have a file locally. If I want to upload it into the Azure storage system, I can use this tool. This function will then fire, because this has a trigger set up on the blob storage system. And this function will just output the name of the blob and the file size. And just to prove it, we'll click Upload, File. And I can click that, hit Upload. This is now being uploaded from my local system to my blob container running inside Azure. And then once it's uploaded, I go back now here, even if it was running. If I come back here, notice the function executed, there's the name of the file, and here's the size. So again, another easy way you can trigger in response to other events and services inside Azure, signaling. So some cool stuff you can do. Now, you might say, this is great for simple 5 lines of stuff, but like what happens if I'm actually building an app? I don't really want to have to develop it inside a text box inside a browser. What if I want to be able to use a debugger in IntelliSense and or test it locally? And so the cool thing is you can do that. And so I'm going to open up a simple example inside VS. You can create any new function app by just doing File New Cloud Azure Function. And look really quickly at a function that I already have. This is the cat moderator app. I have to confess I did not write this app. I'm not a big cat person, but I don't not like cats, just in case I just offended the whole audience. This is kind of a fun app, though, nonetheless, that someone who's really into cats built for me. And basically what this site does is it provides a way that you can upload a picture of your favorite cat, provide a comment, and then if it's approved, it'll show up on the website. And so, kind of a standard kind of approver-like model. Now the difference here is instead of automatic approval, instead I want to use a function so that every time a picture is uploaded, I check to make sure it's a cat and that there's no profanity in the comment. And instead of doing it manually, I want to use artificial intelligence to do it for me. And so it's going to use some built-in, and the way I'm going to do this is with an Azure function. And so this is the function itself. It's called review image and text. And it's going to trigger in response to a message being put in a queue by the web app. And basically what this does is it'll fire, and it calls an API called text moderator and an API called image moderation. And this is calling out to some cognitive services in Azure, which we'll talk about after lunch. And it will look at the image, and Azure will tell you what is in the image. It'll say cat or dog or person or car, and return back automatically what's in the image. And for the moderation, it'll tell you if it sees any profanity or any inappropriate comment. And then basically this just says, if they're both pass, approve the image. So we're going to run this function locally on my laptop. So I'm going to hit run. This is running not in the cloud, but this is running actually on my laptop, the function part, whereas the web app is running in the cloud. And now, so it's going to be a little bit slower just because it's going to do some network traversals all over the place. But now, for example, if I select this cat and I say cute cat, hit create. This just uploaded the cat into Azure Storage, put it in a queue, and that queue is what my local function was listening on. It fired, it called out to the AI services with that image and that text. It just broke in the debugger because I set a breakpoint. And you can see the text passes and the image passes because it has a cat. And I hit continue. It completes, it marks it as approved, and now the cute cat picture shows up on the home page. But who here likes dogs? Feeling left off, so like, hey, let's upload a dog picture. And just say like, oh, it's a cat site, so let's psych them out and go like, it kind of looks like a cat maybe. This is a really cute cat. And we're going to try to just assume someone is blindly just sort of approving stuff without actually checking. And so we're going to hit create. Again, this uploaded this cool dog picture, put it in Azure Image, put it in a queue. This is now going to trigger again that event inside our function. Boom, we're ready to approve it. We've called those AI services. And now if you look in the debugger, passes text. It passed. This is a really cute cat. There's nothing wrong with that. Does the image, though, contain a cat? No, it doesn't. It's false. This is a dog. It's what the AI system said, which means I shouldn't approve it. And now, when I hit continue, it marks it as not approved, which means the dog picture is not showing up there. Instead, it's in the reject folder. And you could, sorry, but yeah. Again, the cool thing here is I'm not running a background service. If 1 million people uploaded pictures simultaneously, this could run the function 1 million times simultaneously. And so I basically have burst capacity. I'm paying only for what I'm actually using, and everything's running on demand. And I've got local debugging and local development for everything. Last thing I'll then just show, and then we'll break for lunch, is one other way you can do serverless inside Azure, which is to take advantage of a capability called logic apps. Logic apps run serverlessly. Where they differ from functions is is about running code. With a logic app, you can basically write a declarative workflow, which can call code, but also can take advantage of pre-built connectors that we already provide for you. So in this logic app I'm going to run here, I'm basically using a connector to Twitter and pulling tweets every 15 seconds that have the hash word Azure in them. I'm calling those AI algorithms to do sentiment analysis to see whether the tweet is positive or negative. I'm using an AI service to do key phrase extraction, so I'm going to categorize all the content that's coming through the system. I can call out to an Azure function, so I can write custom code if I want to as well as part of this. And then I'm pushing it into a Power BI dashboard in real time that'll track the score, the sentiment, the location, and who created it, and update every 15 seconds. And then if it's negative, meaning if someone tweeted something we think might be negative, it's going to push it into a Microsoft Teams room, or I could do a Slack channel, so that my engineers can see, and it's going to open up a support incident in Dynamics 365. I could also push it inside, for example, Salesforce if I want to do that instead. And these are all using built-in connectors. And if I click Add Connection here, you'll notice I've got hundreds of other connectors that I can use. We've got Salesforce, we've got Dropbox, we got on-prem SAP, we got SQL, we got Oracle, et cetera, et cetera. And now when I run this, here, bookmarks, let me show you somewhere here. I can scroll down. There we go. I'm going to open up this Power BI dashboard, and this is showing me now in real time sentiment about Azure all over the world. So each of those dots is where a tweet was actually tweeted, and that score on the left-hand side is basically showing me on a scale of 0 to 1 how positive or negative are the tweets. As you can see, it's pretty good on average. You know, anything above 0.5 considered good, but there's a few outliers. So let's drill into those outliers. And now I can open up my Teams room. Because remember, we're pushing out everything that is below 0.3 into the Teams room. I'll warn you, this is Twitter, so I have no idea what people are going to say. And this is going to basically allow me to see any of those potential exceptions. And one of the things that's hard with Twitter is you only have like 100 and some characters, 140, or I guess now you have more. But and so it's hard to do sentiment analysis with just 5 words. So a couple of these things here are not actually negative. Connecting Microsoft Advanced Threat Analytics to Azure, that's actually probably positive, but it's all threat. And we're at the latest Lost World review. I don't know why they did hashtag Azure, but I guess they didn't like the movie. Yeah, there's a legitimate Azure batch blob not found error in pool start task. And so now my team can actually reach out and say, hey, are you having a problem? Let me help. And we actually use this now inside Azure, and so if you actually do say something bad about Azure, on average within 3.5 minutes, one of our support engineers will actually reach out and direct message you on Twitter and offer to help. And so this type of system is not just a good demo, it is actually what we use inside Azure. And the nice thing is not only did I not have to write basically any code to do it, but if I actually click on here, I can see and monitor this workflow. And so it'll show up in those same log analytic queries that we saw in the same monitoring. And I can even go into any individual execution that occurred. And in this case here, and again, I don't know what it's going to say, so apologize in advance. You can see here, Azure Portal Life Hacks was what someone, I think that's a positive one, but this is what someone basically tweeted. And so I can see the URL to it. I can see on the sentiment detect, oh, and someone is also uploading cat pictures. Good to know. Anyway, it came back as 0.5. The AI algorithm said, I think this is neutral. Here are the key phrases. So cloud, Azure portal, and then it basically pushed it into the Power BI data set. And so I can debug and actually, after the fact, see exactly what happened throughout this workflow in case I want to sort of understand why did some logic happen in a certain way and so forth. So again, this runs serverlessly as well, and the combination of the two really let you build some really cool applications. And Logic Apps with all the connectors let you do some fantastic data integration and app integration workflows. So with that, we're out of time for this morning. We're going to break for lunch now, I think for 30 minutes? 30 minutes. So we'll come back at 1:30, and then in the afternoon we're going to cover AI and a whole bunch more. So see you soon.